Hey everyone, let's take a look at an example where we get together and with our support mechanisms from a previous video in a three-dimensional situation. So let's assume I have a bar. Okay, there's a solid bar here and it might have some weight, right? So we're going to give it some weight and it's supported up here on the y-axis by a ball and socket. Okay, so there's a ball and socket at the y-axis, and then down here on the x-axis there's a roller. Okay, so this is some kind of a roller mechanism on a frictionless surface. So I'm going to assume rolling can be allowed anywhere on the xz plane. Okay, so rolling is allowed anywhere on the xz plane. And then I have a cable attached to it, and it's fixed here at this point, x1, y1, 0, because this bar rather is in the xy plane, so it has a position in the z direction rather of 0. So x1, y1, 0 is the coordinate of this point. And then I'm pulling on it with some tension, T applied. I'm pulling on it with some tension, that's a vector quantity, and that's going to have a position of x2, y2, because it's on the bar, and still 0 in the z. And then this cable is fixed to a point on the xz plane, so it has a position x3, 0, because it's on the xz plane, it has no y position, and then z3. All right, so that's a fixed cable. And what I'm really interested in is what are the forces acting on this bar, so I can look at the sum of the forces and the sum of the moments. Okay, and are there any applied moments? All right, so clearly I have TA is a force, right? So there's a force there, and it's going to have some three-dimensional TA sub x, TA sub y, TA sub z, right? So it's going to have an x component, TAX, TAY, and TAZ. And then there's going to be another one here from this fixed cable, and I'm going to call that T sub F for the fixed cable. And that's also a vector quantity. The magnitude is unknown, but if I know these coordinates, I can figure out the unit vector from point 1 to point 3, right? So I take x3, I take the r3 minus r1, right? So T fixed will equal some magnitude times r3 minus r1 unit vector. Well, better do that, be careful with that. So r3 minus r1 over the magnitude of r3 minus r1, right? We've done all this before. This is the unit vector along this cable, right? So position 3 minus position 1 divided by the magnitude of that displacement. Position 3 minus position 1 is a displacement from 1 to 3. Divide by that displacement, and that gives you the unit vector along that displacement. Multiply that by T fixed, and we figure out the vector direction. We'll assume T fixed is the only unknown in this situation. These two positions are known. Okay, at the ball and socket, there's going to be, I'm going to call that ball and socket, so BX, there's going to be a BY, and there's going to be a BZ. So the ball and socket exerts forces in all three directions, right? That exerts forces in all three directions, but it exerts no moments. So I'm not going to put any moments on this diagram because it exerts no moments. And then over here at the roller, remember the roller is on the XZ plane, and it's free to move anywhere on the XZ plane, but it can't move down the XZ plane. And so there's going to be a force in the Y direction. I'm just going to call it R sub Y. There is no RX, there is no RZ. So that's the roller force, and it's purely in the Y direction. All right, so these are the forces acting on this bar. I better put a weight in here, some W, and that's of course going to be strictly in the J direction. Put a minus sign there. So minus W, that's the weight of the bar. I'll assume it's in the middle of the bar, so I have to go from here to here to figure out what that position is. So I'm going to have to know those points. Okay, we can assume that's given. And then that would be the weight of the bar. So I've got this system right here. Let's assume TF magnitude is not known, right? The roller force is not known, and then BX, BY, BZ is not known. We're going to assume T applied, the T applied tension is known. So I end up with what? 5 unknowns here. Oh, yeah, 5 unknowns. Right? I end up with 5 unknowns, so I'm going to need 5 equations. And that can come from the sum of the forces in the x, the y, and the z, and then the sum of the moments about some point. So you'll pick a point and find out what the moments are about those points. And you should be able to get enough equations to solve for your unknowns. But this is what the force diagram will look like. Okay, if I were defining these forces, this would be a tension due to this rope acting on the bar. This would be a tension due to rope 2, the fixed rope acting on the bar. This would be a gravitational force due to the earth acting on the bar. This would be a normal force due to the surface acting on the bar. If you want to say due to the roller, that's okay. I like due to the surface better. And then this is a normal force due to the ball and socket acting on the bar. And the normal force has an unknown direction, because it can be in any direction in the XYZ plane, or the XYZ space. And so I break it down into its components. But we'll consider that to be a normal force due to the ball and socket. All right. If you have any questions, please leave them in the comments below. Thank you.